All right, as promised, we're going to learn about logarithms, and it doesn't have anything to actually do with logs. It's just thought it'd be a nice picture. All right, so here's what a logarithm is. It's the inverse of an exponent. So the same way that multiplication is the inverse of division, logarithms are the inverses of exponents. So what a logarithm does is it tells you what exponent would give you a certain result. So looking at this first example, we have the way we'd read that, we have log, which is short for logarithm, and then we have this little 3, and then 81. And the way you would read that is log base 3 of 81. And I'm going to go ahead and point out that this is called the base. And the base in a logarithm is the same concept as the base when you have an exponent. So here's the idea. With an exponent, you would say 3 to the 4th power equals 81. And that's what the exponent means. 3 times itself 4 times is 81. With a logarithm, you're going the other way. You start with 3 still, that's your base, and then you get 81, and you're saying, what power, what exponent could I apply to 3 that would give me 81? So you go through your powers of 3, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. So the answer of this logarithm would be 4. It's the exponent that would take you from your base to this number here that you're taking the logarithm of. So the next example here, it's the same concept, but what you'll notice here is there's no little number next to the word log. And if there's no number right here, then it's an understood 10. 10 is your standard logarithm. So whenever you just see the word log and there's no little number next to it, you understand it to be 10. So you have the 10,000 here. So you're thinking 10 to what power equals 10,000? And the nice thing about powers of 10 is you can just count the zeros. So 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000, and then it'll be 10 to the fourth power. So I didn't mean for both of those to be 4s, but I guess they are. But that's how logarithm works. Instead of using the exponent to find a value, you have the value and you're trying to find what the exponent is. All right, so we're gonna do some different kinds of examples here. And the first thing we want to be able to do is just rewrite these as exponential equations. We want to go both ways. We want to be able to take an exponent equation and write it as a logarithm, and we want to take a logarithm and write it as an equation with an exponent. Because when we get into different types of word problems, you'll find situations where we have to rewrite something, and we want to be pretty comfortable being able to do that. So the way we're going to do this is just keep in mind that this number here that it's equal to is the exponent. And the little number next to the word log is the base, and those are already numbers we're familiar with. So we have a base of 4, an exponent of 5. So we would rewrite this by saying 4 to the 5th power is this number right here, 1,024. Down here, our base is 1/2. So we'd say 1/2 to our exponent's -4. The -4 power is 16, our result. And then the last one, again, we don't have a base written down there, so it's understood to be 10. So we'd say 10. Our exponent over here is the 3, and then that's equal to 1,000. 10 to the third is equal to 1,000. So that's how you take a logarithm and rewrite it as just a regular old exponential equation. And you can do that just with regular numbers like this, but often you'll also do that with variables involved. And what you'll find is usually one equation or the other will be easier to solve. So if you can switch back and forth, it gives you more options. All right. Next set of examples is we're going to go the other way. We're starting with the exponential equation. We're going to write it using a logarithm. So again, keep in mind, what is your base? And what is your exponent? And remember, with a logarithm, the base is still the first number. The exponent is what it's equal to. So our -3 here will go on the other side of the equal sign. Our answer here is going to be right here. It's the number we're taking a log of. So this would become log base 6 of 1 over 216 is equal to -3. So here we've got 8 to the 4th power equals 4,096. 8 is the base. It goes next to the log. 4 is the exponent. It goes on the other side of the equal sign. And then we're going to take the log of 4,096. So that goes right there in the middle. The last one, we have a 10. And so we know with a 10, we don't write the base. We just write the word log. Our exponent is 0. And then the number we're working with here is 1. So we'd say log of 1 is 0. And what you'll find is, regardless of your log base, anytime you're taking the log of 1, it's always going to be 0 because anything to the 0 power is 1. So that's something to keep in mind too. So that's how you go back and forth from exponential equations to logarithms and vice versa. So let's look at some other stuff here. So here this is like the first 2 examples I gave you. We have to evaluate these. We have to figure out what the answer is. And the way you want to think of this is by asking yourself the question, what power, or if you don't like the word power, I'm not crazy about the word power, I don't know why, what exponent? That's what you're looking for. What is the exponent or the power that takes you from one number to the other? So in this first example, we have log base 2 of 8. So we're thinking, what exponent gets me from 2 to 8? What power of 2 is 8? So you can just kind of go through it. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Here we have a fraction. So we have 5, and then we have 1 over 625. And we're thinking 5 to what power is 1 over 625? So here's the way I like to think about this. I know I'm not going to get a fraction just taking my regular powers of 5, but here's what I can do. I can think 5 to the first power is 5. 5 to the second power is 25. And I keep multiplying by 5. I get 125 for 5 to the third. And I end up getting 5 to the fourth is 625. So to make that into 1 over 625, the way I would get there is by making my exponent negative. So, because remember, negative exponents give you the reciprocal. So I'm probably writing more than I really need to write here, but just to make it really clear where this is all coming from. The exponent that would give me 1 over 625 would be -4. So that's going to be my answer. 5 to the -4th power equals 1 over 625. So those are a little trickier. Again, the way I think through it is I forget about the fraction at first and just focus on the bottom number. And then whatever exponent would get me to the bottom number, I then make that negative. All right, here we have a really big number here. And without commas, I can't just look at that and even know what it is. But I do know that this is a log base 10. And I know that whenever you do powers of 10, you just keep adding zeros. And the way you can figure out the exponent is by counting the zeros. So I'm going to count my zeros. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this thing would be 10 to the 9th power. So powers of 10, just count the zeros. That's the quick way to do that. Now the last one, I have an exponent in the logarithm, which looks a little weird, but it actually makes this easier on us. Because remember, the question we're asking here is what power or what exponent. And so we're thinking 7 to what power is equal to 7 to the 6th. And if you think about what we just said there, it's kind of obvious. 7 to the 6th power is equal to 7 to the 6th power. So whenever you have an exponent in a logarithm, if the bases match like this, then you're just going to basically rewrite this exponent again. Because 7 to the 6th power gets you 7 to the 6th power. So that's how you simplify or solve these when they're just written in this form. But of course, a lot of times we're not just working stuff out. We've got variables we've got to figure out. So there's a couple different types of problems here. And the biggest thing to do here, or the trick here, is just to remember and keep in mind what the x represents in each of these equations. Because sometimes you're going to be looking for an exponent, and sometimes you're going to be looking for the final result after using the exponent. So always remember, like we've already talked about, and I know I repeat it, but it's really important, that this first little number is your base, and that the answer on the other side of the equal sign is your exponent. So on something like this first one, what this means is this means 3 to the 4th equals x. So to solve this, to figure out what x is, what we need to do is just figure out what is 3 to the 4th. And 3 to the 4th power is equal to 81. So we would say on this one, x is equal to 81. So 3 to the 4th power gives us 81. On the second one, the x is in a different spot. The x is the exponent. So this becomes like what we did on the last slide. So we are thinking 5 to what exponent equals 125. So you want to go through your powers of 5. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. So on this one, x is equal to 3. So on that one, you're finding the exponent. So that's the trick. Are you finding the exponent, or are you finding the result of doing the exponent? All right, the third one, this would be a 10. So log base 10 of 1 over 1,000. So we're thinking 10 to what power is 1/1000th. And same way we did this on the previous slide, I'm going to forget about the fraction and just focus on the 1,000 and figure out 10 to what exponent gives me 1,000. Well, that would be 10 to the third power. So to get the fraction 1 over 1,000, I just take that third power and I make it negative. So here x would be -3. So 10 to the negative third power equals this right here, this 1 over 1,000. All right, last one. Here it's kind of like the first one, where the x is what we're taking the log of, and we have an answer here. We have something on the other side of the equal sign. It's our exponent. So we have 7 as our base, -2 as our exponent. And so this is just one we have to work out. So we take 7 to the positive second is 49. Because it's negative, we do the reciprocal. So it'd be 1 over 49. So x is equal to 1 over 49. So 7 to the negative second power is 1 over 49. So there are going to be more complicated ways to solve for x using logarithms, but for right now, I just want to make sure we get this down. And again, pay close attention to what the x represents in each of these equations. All right, last thing to go over here with logarithms right now is what the graphs look like. So we're going to do 2 of these. So this is a log base 2 of x. So here's how we're going to do this. When we start plugging in numbers for x, the numbers we need to plug in are powers of whatever this base is. So we need to start by plugging in powers of 2. So I'm going to write these just up here at the top. Our powers of 2. The first power for every number is 1. The second power is always itself. And then we've got, if we keep doing powers of 2, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that we got those numbers. That's what we're thinking about here. And I'm going to go ahead and actually start down here, because we're going to go backwards and get a couple fractions. So if x is 1, here's what we're asking. If we plug in 1 for x, we're asking 2 to what power is equal to 1. And the way we get 1 using an exponent is by plugging in a 0. So the answer here would be 0. Log base 2 of 1 is 0. Now we're going to go to 2. Log base 2 of 2. Well, the way you get 2 using an exponent of 2 would be 1. 2 to the first power is 2. So we put a 1 there. So what you're getting here when you do this, it's the same values you would get if you were graphing 2 to the x. It's just they're flipped. The numbers that were on the y side are now on the x side. The numbers that were on the x side are now on the y side. So let's do the next one. And again, we're not going to plug in 3 because I don't know what power of 2 is going to get me a 3. It's going to be some weird decimal. But I do know 4. I know 2 to the second power is 4. So when I plug in 4, I get 2. And I'll do one more. I'll do 8. And I know that 2 to the third power gets me 8. So that gets me some points that I can graph. But again, I don't want to just do the numbers that like with positive integers. I want to do some fractions too, and some negative numbers. And the way that's going to work is I'm going to take my reciprocals. So I'm going to start with 1 over 2, and the exponent of 2 that gets me 1 over 2 is -1. 2 to the -1 is 1 over 2. And then I'll do the same thing with, I'll do 1 over 4. And that would be 2 to the -2. So again, we have the same kind of symmetry on our table here that we did before with exponential equations. It's just the numbers, which side they're on, gets switched. So let's go ahead and plot some points here. So when x is 1, y is 0. When x is 2, y is 1. X is 4, 2. And when x is 8, we're at 3. So you can kind of see where it's going. It's coming up and kind of flattening out. There is no horizontal asymptote here, though. I want to be clear of that. It will continue getting gradually bigger, even if it does so very slowly. But on the other end here, let's plot these out. We have a point at 1/2 -1. And we have a point at 1/4 -2. And if you wanted to go like 1/8 -3, you could do that, and it's just going to get closer and closer to the y-axis. So here, the y-axis actually is a vertical asymptote in this function. So it's going to look something like that. That's what your logarithmic functions look like. All right, we're going to do one more. This time with a fraction. All right, and these involve math that you've already done, but it's a bit of a headache just keeping track of everything and thinking through it. So here's the way we're going to think through this. We're going to do log base 1/2, and we're going to just take our powers of 1/2. And again, we are going to start with 1. And the exponent that always gives us 1, because remember, the answer to these log equations is always the exponent. 1/2 to the 0 power gives us 1. So when we plug in 1, we get a 0. All right, now we're going to use the number itself. So log base 1/2 of 1/2. Well, 1/2 to the first power gets us 1/2. So if we plug in 1/2, you know what? Well, this is going to look funny. The numbers are going to kind of end up being backwards, but it's okay. So when we plug in 1/2, we get a 1, because 1/2 to the 1 power is 1/2. Let's do a 1/4. Well, what power of 1/2 gets us 1/4? Well, 1/2 times 1/2 is 1/4, so that would be the second power. And if you want to, I'm going to squeeze in 1/8, and that's going to be a 3. All right, so now let's go the other way. We're going to go get some negative results here. So think of log base 1/2 of 2. Well, 2 is the reciprocal of 1/2, and the way you get a reciprocal is by taking something to the -1 power. So if I plug in a 2, I get a -1. Let's say we do log base 1/2 of 4. Here we're taking the reciprocal and squaring it. So that's a -2 power. 1/2 to the -2 power is 4. So if I plug in a 4, I get -2. And if you want, you could plug in an 8 and get -3. So that's what that's going to look like. And let's go ahead and plug in some of these points. So I have an 8 -3. I've got a 4 -2. I've got a 2 -1, a 1, 0. And then I've got 1/2, 1, 1/4, 2, 1/8, 3. And just as before, the y-axis acts as a vertical asymptote. And we end up with, when we take the reciprocal of the base here, we end up with a reflection of our original function, a reflection over the x-axis. So that's what that's going to look like. I will say on this assignment, you do have a couple graphing problems, but they don't actually involve a fraction. That could come up later, so I want you to be aware of it. So that's logarithms. I know that covered a lot of stuff. That my hope is that the types of problems we're doing right now are ones that are just about understanding what all the numbers represent. And my hope is they won't take too long. And then what we're going to do is we're going to bring in the work you did on that compound interest assignment. We're going to mix that in with our logarithms and some other stuff. And we're going to start seeing how we can use these exponential functions and logarithms to solve some real world type problems. So that's logarithms, and yeah, I'm not very good at closing these videos, so I'm just going to cut it off right here.